In this video, I'm going to be talking about function pointer, passing a function to another function, and array of function pointers. So I'm going to be using this editor and this skeleton code to explain function pointer. So like we have the pointer to point to integer. So if this is an integer pointer, and we can use this pointer to point to an integer data. If I have integer data with name x initialized to 5, then I can use to hold I can use this pointer to hold address of x, which is essentially pointing to x, right? Similarly, if I want to have a pointer to point to a function, right, let me create a function first. So this is a function to print text called hello. The function name itself is actually, you can assume this as a pointer, address of the function. What actually happens is this entire logic that is included inside the function definition is actually stored in one place in a memory, and name actually is linked to that memory address. So when you call that function, it control goes to that memory space and starts executing the statements one by one. And once all the statement is execution is done, then it will come back to the place from where it is called, right? So it's important, if you have access to that address, then you are able to call that function, right? So we want to be able to access the address where the function is actually stored. So you can specify the address using the name, or you can also specify the address by putting ampersand address operator before the name, right? But to use this address, you need to have a variable that is able to hold this address. So function pointer is a variable that is able to hold address of function. So you need to be able to create a function pointer. The syntax for creating function pointer is kind of you can compare with this the approach you use to create a variable pointer. First, you need to have a type of the function, right? You need to have a type. In this case, in the case of variable, you need to have a type of variable, which is integer in this case. So we need to have type function, and type of function, it can be specified like this. All the return type and the parameter types, they actually constitute the type of the function. If I put things like this, now this is the type of the function, right? So in this place, and in other words, you can just copy the first line of the function, and you can see this as a type, except this one, name. Just remove the name, then everything else is a type, right? If a function is to receive the data in its parameters, and it will have a type of the parameters inside the parenthesis, right? But name, I didn't include the name because the name is itself the name to identify the function to the function, like in the case of x, but we only need type. So we put parenthesis here, and we put asterisk to indicate that it is a pointer, like you have things like this, asterisk, and then followed by the name of the pointer. So we want to have asterisk and followed by the name of the pointer. So now in this case it's going to be fptr is going to be name of pointer that is able to point to or hold the address of a function of this type. Right now, with this statement, with this fptr, so with this this pointer now actually points to this function. You can set the address to the pointer in different ways. You can directly set the name, or you can set the address, or it's also possible that you can initialize in this place, or you can also initialize to the address. Right, so the different way of initializing the pointer to the address of the function. I'm going to be using this approach, but this is a very simple approach, simple and clean approach. So let me use this. Now if I want to call this function, I would be calling like regular function. You can assume that if you assume that this is the name of the function, then you can call in the way you would be calling that function using the name. For example, I would call this print hello function like this using function pointer. I would call it by using the name of the function pointer like this. So this is a way of calling the function using function pointer. This is a way of calling function using the name itself. So I'm going to be executing this code, show you the output, then I will continue with this discussion. So let me go to the output window. Before that, I want to make sure that I save the file. So compile. Oh, there's a problem. Let me go back to the editor and make correction. It says that this is declaration. So we have, looks like we have multiple declaration of xptr. So we cannot have multiple declaration of the same name. So let me remove this, save it, go back to the output window, compile again. Now there is another problem. This is a warning, it is not used. So if you set the variable but not use it, if you define a variable but you don't use it, it actually complains. So let me put these things in comment. Now it compiled. Now execution. Now there are two outputs hello displayed. One was through the execution by calling the function through the name. Another hello was displayed by calling the function through pointer. Right now, this is a function that is created to point to a function of this signature. Like this was a pointer to create a variable of type int. So therefore this is a pointer created to point to a function of this type. If the type of the function differs, so if I want to receive, I want the function to receive the name and use the name in the displayed message like this, right? So now the type of this function and this function are different because of the presence of parameter. Now you cannot use the same pointer to point to this print hello, right? For example, if I comment, because there are two versions of this function, overloaded version of this function, so it will select the function that actually matches the type of the pointer. But if I remove this type, then it will not be able to match Now it will this setting pointer to print hello will actually be setting this pointer to attempting to use this pointer to point to this function, and the type of this function does not match with the type of the pointer, therefore this is now illegal, right? So if you want the pointer to point the second version of this hello print hello function, then you need to create a pointer for that corresponding type. Let me give name fptr2 and type is going to be string. So now with this we have this function, and you can initialize right. So now it has created and initialized to print hello. So to call this function you need to pass the name to the parameter, some string to the parameter, right? So let me save this first, transition to the output window, compile again, compile and run. Now you can see this is the outcome of the invocation of the second version of print hello function by using the second pointer we created. Right. So if we have a different signature function with different signature, then we need to create another function. So it's I mean, if there is a slight change, change in the type of the function, then you need to create another function. But if I have another function with the same signature, for example, display comment, so if I'm displaying in different way, in this case the type of this function and this function is same, so we are able to use this function pointer to point to the second function. fptr equals to display comment. So with this we are able to call function with comment right. A quick brown fox jumps over the lazy dog. So let me save it, save this code again. Before I run, just pay attention to the function print hello. It has a return type void, parameter type string, display comment, return type void, parameter type string, so they have the same signature, and we are actually reusing the pointer that was created to point to print hello function to point to the new function, display comment function. Let's see the output. Now you can see this was displayed, but this was the outcome of the second invocation of the second version of the function, this display comment function, right? So If signature is same, then you can use the same pointer to point to all the function with the same signature. But if signature differs, then you need to create a different pointer. Now one word of caution: if you in this function when creating this pointer to function, in case if you remove this parenthesis, this will essentially be a prototype of a function called fptr, which does not receive anything but which returns void pointer. Or if in case return type is int, then in case this will be a function which does not receive anything but returns address of integer type variable. So be careful, do not remove this parenthesis around asterisk and the name of the pointer is necessary. Another word of caution is or another tip or information about this pointer is, it's also possible that you can use this by dereferencing. That will make the code a little bit more complicated, but it's possible. Good to know about this. So you can dereference this and to get evaluate the address of the function itself, and then you can call this like dereferencing in the variables. Okay, this is also the valid way of using function pointer, but generally I don't recommend this. You need to make code as clean and simple as possible. Okay, now I'm going to be talking about how to pass one function to another function using function pointer. So here let me clean this code a little bit to make space for the discussion. So if I want I have this print hello function, and I want to pass this function to another function. Right, if for example this display function is to display some message, it is to display some message. But if you want to call this function in different way so that this greeting is actually displayed differently, right? In that case, it's possible that you can have this kind of display function, or a function that returns. Let me have the display function, one print hello function, another let's say printing in different style. Suppose this function only prints this text, and this function prints in different style, and another function another style similar to this, but with more text in it. So I have this three different styles. I actually want this place to be filled in by either this display or this display, and then the name of the person for which the greetings is to be displayed. In that case, I want this function to be able to call those functions. Print hello. In this case, you can directly call it because they are defined here, but this is not always case, because this display function can be in one model. You can have this function in another model, right? So we want flexibility of being able to pass this function inside this display function. So you need to receive that function as a parameter in the parameter, and you need to specify the type. Like while receiving the variables, you have type followed by the name. Similarly, to receive the function, you want to have a type, void, and the name of the pointer and the parameters. So this is the type you specify here. With this, you are able to pass the function, and inside you can call that function. Just call that function and followed by the text you want to print here. So if we do like this, then we are able to call this function by passing any one of these functions, because the signature of all these functions is return type void and no parameter types, no parameters at all. So let me use this, have a code to use this. First, I want to pass print hello. So now I'm calling this function by passing this print hello function into this pointer, and this pointer is being used to invoke from inside. Second, next, I want to call the same function by passing print style. And third, print style too, right? So you can see, so first invocation receives print hello function, second invocation receives print style function, third invocation receives print style 2 function. Let me show you the output. Now you can see in the first case it was hello zone was printed because it was called and there was no new line character after that, so it was displayed. In the second case, hello was printed with some style in it, and the name of the person is printed in the next line. In the third case, different style, hello printed, and the name is printed in a different line. Okay, you can see the difference. So passing a function to another function gives flexibility. Next, I'm going to be talking about array of function pointers. So like we can have the pointer in the case of variables, we can have a pointer, and we can also have array of pointers, right? Similarly, in the case of function pointer, also we can have function pointer, and we can also have array of function pointers. So now in this case, this is the function pointer definition. This is the array of function pointer definition. The only difference is you need to put this bracket, like after the name of the pointer, you put these square brackets and the number of elements in the array inside the square brackets. That's the only difference. With this, you are able to initialize this to the function with the same signature. We have already 3 functions here: print hello, print style 2. So we can initialize these 3 elements to this function. Print style 2. Now Now in this case, this gives use of array gives more flexibility. In this case, I don't need to write this. So sometimes I may have maybe 50, 100 different invocation of display function. In that case, if I put everything in this array, then I can put entire thing in a loop. Then I can have only one display function invocation with and we can pass. We can use the pointer, the array to pass the different functions in it. Right. So print hello is going to be the first function to be the function to be pointed by the first element of the array. Print style is going to be the function to be pointed by second element of the array. Print style 2 is going to be the function pointed by the third element of the array. So in this iteration, in the first iteration is going to be first function that is passed, and then second and third function passed. Output, it is showing me warning because I have not. Let me ignore that warning. Okay, so I think I should be able to run this by ignoring the warning. So now you can see the same thing being done by using the array of pointers now. Okay, now I'm going to be I will actually use a bit different, maybe a bit more interesting example to demonstrate array of pointers. For example, I have a function to compute summation of two integer values, and another function to compute subtraction. Multiplication. So I have 4 different functions. With all these functions have same signature, so I can have a function array of function pointer to hold the address of all these functions. Let me create a array of function pointer of size 4. Now you can see we have to have return type of the function is integer, so we have integer in this place, and it has 2 parameters, so int 2 parameters, and we have name of the function pointer asterisk and the number of elements in the pointer. We can initialize to all these functions. Right, so now I can use this the same situation, same function in iteration. I equals 0, I less than 4, I plus plus. I 5 6. So different iterations will actually compute and display either addition or subtraction, multiplication or division. Now you can see the addition first in the first element, actually first element of the array pointed to sum, therefore summation was computed in the first iteration. Second element pointed to subtraction function, so subtraction 5 minus 6 equals to -1 was computed. Third pointer pointed to multiplication, so 5 times 6 equals to 30 was computed. And fourth division, 5 divided by 6, and if you have integer types, then integer division takes place, therefore the outcome of the division of 5 by 6 is 0. Okay, that is it. This is the end of this video.